All right, for 12C, we're supposed to find the domain, X-intercept, Y-intercept, vertical asymptote, horizontal asymptotes. We're just continuing the process from before, and we've got a few more of these problems to do. So the domain should be found really before you simplify. But now that doesn't mean we can't go ahead and factor. So that's 2 times x plus 2 divided by 2 minus x. Now notice these problems all look very, very similar. But they're slightly different, and that's why I picked these out. So the domain here is x cannot be whatever makes the denominator equal to 0. So I say 2 minus x is not 0. You could put equal to 0 is fine. Add the x over. So 2 cannot be your x value. So that means negative infinity 2 with a parenthesis union 2 to infinity is your domain in interval notation. In other words, x is not allowed to be 2 ever because it makes the denominator 0. Next thing we're supposed to do is find x-intercepts. To find x-intercepts, you substitute 0 for f of x or for y. So 0 equals 2. Now you can use the factored version or the original version. If by chance this polynomial simplified, use the simplified version to find the x-intercepts just in case one of these values that's not in the domain ends up being a solution. Okay, now to solve this, I'm going to multiply both sides of this equation by 2 minus x because you can't solve for an x when it's in the denominator. So 2 minus x over here and over here. The 2 minus x's cancel, and we're left with 0 equals 2 times x plus 2. The next thing I'm going to do is divide by that 2. So 0 is equal to x plus 2. I'm going to subtract the 2 over. Get x equals negative 2. Now this is an x-intercept, so I need to write it in point form. Now the y-intercept I'm going to do right over here to the right. That's when you let x equal 0. So that's going to be y is equal to, you know, y and f of x are the same thing. Y is equal to 2 times 0 plus 2 divided by 2 minus 0. Or you could use the original 2 times 0 plus 4, no parentheses, divided by 2 minus 0. You should get the same answer. That's 2 times 2 is 4 in the numerator. 2 in the denominator gives me 2. Again, this is a point. This is the point 0, 2 is my y-intercept. What about vertical asymptotes? Now, vertical asymptotes should always be found after your polynomial is simplified. But remember, this one doesn't simplify anyway. So you need to set the denominator equal to 0 and solve. If I add x over here, I get 2 is equal to x. We like it better when the x is on the left, so x equals 2 is your vertical asymptote. What about horizontal asymptote? Okay, that's the 3 cases. So I'm looking at leading coefficients here. Okay, leading coefficient, well, not yet, my bad. I'm looking at degrees. The degree of the numerator is 1. Look, the degree of the denominator is also 1 whenever your degrees match, which has been true for every problem we've done in the review so far. You have y equals, now this is going to be leading coefficient over leading coefficient. So the leading coefficient of the numerator is 2. And this is the tricky part. This is why I picked this problem. The leading coefficient of the denominator is negative 1. So it's y equals 2 divided by negative 1, which results in negative 2. So y equals negative 2 is your horizontal asymptote. Now the idea of making these problems so similar yet different is so you can compare and contrast. Next, I want to take all of this information and put it on a graph. First, note the x-intercept was negative 2, 0. My point's not plotting. And the y-intercept was 0, 2. I need to go back and verify that real quick. So negative 2, 0, yes, and 0, 2. My vertical asymptote, which is going to be represented as a vertical dash line at x equals positive 2, but my horizontal is at y equals negative 2. Okay, so in a different color at x equals positive 2, got a vertical dash line, and at y equals negative 2, I have another vertical dash line. What's the significance? The vertical, a horizontal dash line. Did I say that right? The vertical, okay, the graph will never, ever, ever cross. The horizontal, it is possible that the graph intersects the horizontal line, but it will still approach it and not touch it near the outside. Okay, now, I'm going to go back to my orange because I'm going to grab, actually, let's plot some points. So, XY axis down here, T-table down here. Okay, what do you want to plug in? Well, the rule is you have to plug in a point between and beyond every x-intercept and vertical asymptote. So I need another point out here. Okay, so -3, -4, this is -5 at the edge. All these edges are your 5s, not the -4s, what it's closer to, but the edges. Okay, so let's plug in, for instance, how about -3? So that's something on the left of this x-intercept. I need something on the right of this x-intercept. Actually, I have something already 0, 2 plugged in. So I'm not going to plug in anything between -2 and the vertical asymptote. But I definitely need something on the right side of the vertical asymptote. Like, for example, 3 or 4 or 5. So I'm going to plug in +3. Now that's going to be 2 times -3 plus 4 divided by 2 minus, careful here, and I almost wrote that incorrectly. It's going to be 2 minus, which is in my formula, and then our function, and then -3 is the value I'm plugging in. So this is -6 plus 4 in the numerator, and 2 plus 3 in the denominator. -6 plus 4 is -2, 2 plus 3 is 5, so -2/5 is what I get when I plug in -3. Let's go ahead and plot it. So -3 and then -2/5. So not quite halfway in the negative direction. Good enough, right? Okay, and let's plug in 3. So that'd be 2 times 3 plus 4 over 2 minus 3. 2 times 3 is 6 plus 4 is 10, divided by -1, so -10. Once again, I was off on the scale that I gave you, but that's okay. We can work that out. So I'm going to plot the point 3, -10. So 1, 2, 3, and then -10. I'm going to put it, y'all, right here, but we actually know it's lower than that. And we'll see what that means about our graph in just a minute. Now, on the left, I think it's clear what's happening. Okay, so you see it kind of curves right here. Now here we have an option of going up or down. But I know it doesn't go down because I'm not going to make a new x-intercept that doesn't exist. We found the only x-intercept that there is, and we've already plotted it. So this must be going up to approach that vertical asymptote at x equals 2, and it must swoop down and approach that horizontal asymptote at y equals -2. What's happening over here, again, that point is so low, but I'd imagine that curves and approaches there and then goes straight down and approaches. Now, if you didn't feel comfortable about that, probably plugging in another point would be good. For instance, 4. Let's just do it. If I plug in 4, it'd be 2 times 4 plus 4 in the numerator divided by 2 minus 4. 2 times 4 is 8 plus 4 is 12 in the numerator. 2 minus 4 is -2 in the denominator. 12 divided by -2 is -6. So at the point 4, I should be at -6. And notice I'm up here at -4. So it's a little bit lower. It actually curves more like that. Is that okay? Yeah. I would give you full credit for either one because we're just trying to get a rough idea of what this looks like. It's not going to be perfection, especially if you're just plotting one point on in your little area. Okay? It'd definitely be enough to match the correct graph. Okay, so for example D, again, it looks like a problem we've already done. The rule is to simplify first. So that's going to be 2 times 2 minus x in hopes that something will simplify, but it doesn't. So we factored, nothing cancels out. So what it means, we can either use this when we substitute in values or use this one for any of our calculations because nothing cancels. All right, so when you find the domain, you set the denominator equal to 0. Better yet, not equal to 0 because x is not allowed to be that value, which is -2, which leaves me going from -∞ to -2 and then union -2 to infinity. Everything else is fair game. To find the x-intercepts, you substitute y equals 0, which is really the function equal to 0. So I have 0 equals, now again, you can use the factored one or the unfactored original. It doesn't make any difference. It really kind of just depends on what you feel more comfortable solving. The steps are very similar. First of all, you got to get rid of that variable in the denominator, so I multiplied both sides by x plus 2, and that's going to give me 0 on the left still, and 2 times 2 minus x on the right. Now I've got to get rid of this 2 right here, so I'm going to divide both sides by 2. So it's going to give me 0 equals 2 minus x, and I'm going to add the x over to get x equals 2. In point form, that's the point 2, 0 is my x-intercept. My y-intercept, you always substitute x equals 0. So you're going to have y equals, because f of x and y are the same, and then you're going to have 2 times 2 minus 0 over 0 plus 2. Again, up to you whether you use the factor one like I did, or you use the original function, because nothing's simplified originally. Those 2's cancel, so you get 2. So your y-intercept is going to be the point 0, 2. Careful what order you write those in. I've already found myself making mistakes just writing that backwards because I'm doing it too quickly. Just trying to make the video not like 8 hours long. Alright, so the vertical asymptote, remember the rule is there, you simplify first, then you set the denominator equal to 0. Well, we tried to simplify it. It wouldn't simplify, so there's your vertical asymptote right there when I set the denominator equal to 0. What about the horizontal asymptote? That happens when you look at your cases. Okay, what do I mean by that? The degree of the numerator is 1. The degree of the denominator is 1. So whenever the degrees are the same, like they are in this case, they're both 1, your answer is y equals leading coefficient. Now let's highlight the leading coefficient. The leading coefficient of the numerator is actually -2. The leading coefficient for the denominator is +1. So your y equals -2 divided by +1, which of course is -2, or y equals -2 is your horizontal asymptote. Transfer this information onto a graph. So I plot my intercepts. 2, 0 is 1. It won't plot. There we go. 0, 2 is the y-intercept. I'm going to go back and take a look at my asymptotes. They're both -2. X equals -2 and y equals -2. So x equals -2 is over here on the left, and y equals -2 down low. Okay? Now again, you're required to, when you plot points, I say you're required. If you want a decent looking graph, this is what's required. You need to plot between and beyond every x-intercept and vertical asymptote. So there's a vertical here. I need something on the left-hand side of this vertical asymptote. So -3, -4, even -5 right here at the edge will be fine. Let's plug in -3. That's what we've been doing. And I need something on the right of this vertical asymptote and before this x-intercept of 2. And we've already plugged in something, 0. I'm going to remind myself I did it, 0, 2. And then over here on the right, something to the right of that of that x-intercept, and that might be 3 or 4 or even 5 here at the end. Let's just do 3. I plug those in my original function or the factored one. If by chance your polynomial simplified, you want to use the simplified version. So this is going to be 4 plus 6 because these two negatives cancel to give me 10. -3 plus 2 is -1. When I divide that out, I get -10. When I plug in +3, 4 minus 2 times 3 over 3 plus 2. That's going to be 4 minus 6, which is -2. And 3 plus 2 is 5, so I get -2 fifths. Once again, I'm trying to plot 10 on a graph that doesn't have a 10 on it. So I'm going to do the best I can. -3, -10. Way, way, way down here. I'm just going to put it there for pretends. Okay. 0, 2 we've got plotted, and 3, -2 fifths. So -2 fifths is small. It's almost a half. -2.5 fifths is a half. Now, over here, okay, I know that I've got to be approaching this vertical asymptote right here, and it's going to come out and approach the horizontal asymptote. And here, I've got to be going up to meet my vertical and coming down to meet my horizontal. I know your options when you're going towards a vertical asymptote, either run up the wall or go down the wall. I know it doesn't go down the wall because I'm not building a brand new x-intercept, so this one had to be running up the wall. You see what I mean? Now, one thing I haven't been addressing, and I keep saying I'm going to, is does the graph cross the horizontal asymptote? So does it cross the horizontal asymptote? To do that, all you do is you set the horizontal asymptote equal to your function. Okay, so horizontal asymptote is down here at -2 equal to 4 minus 2x over x plus 2, and I solve that equation. Now to solve this equation, I multiply both sides by x plus 2. So an x plus 2 on this side and another one on this side. I distribute over here. So that's going to result in negative 2x minus 4 on the left and 4 minus 2x on the right. Okay? Now, if you'll notice, to get all my x's on one side, I could add 2x or I could subtract 2x. Either way, your x's disappear, and you end up with a statement that negative 4 equals 4, and that's not a true statement. There's no solution, so I know it does not cross. If I got an answer like 1, that means it would cross the horizontal asymptote at 1. And I'm not sure that any of the problems I gave you in this review actually intersect the horizontal asymptote, but I've shown you a couple of times how to find out if it does. Now finally, a problem that looks a little bit different. It's the same directions, but we have a different looking function. So again, advice, go ahead and simplify this function. This is 6 over. Now the denominator will factor, multiplies to be negative 6 and adds to be negative 1. We're talking x minus 3 times x plus 2. But now, can I cancel anything out? No, you can't. So in the same fashion as the last 4 problems, it factored, but nothing canceled out. Okay? So that means my domain is just the denominators equal to 0. Well, if it's factored and equal to 0, that means each factor equals to 0, and I get x equals 3 and x equals negative 2. Really, we're taking those out of the domain. So my domain goes from negative infinity to the lowest number, which is negative 2. It picks back up and goes from negative 2 to 3, and then the graph picks back up again. I need a union symbol or a comma in between here, and it goes from 3 to infinity. That's my domain. Domain's what you're allowed to plug in. Where it's undefined is what you're not allowed to plug in. It's really the same question. So the homework will ask a lot about undefined, and you would just type in negative 2 and 3 is where it's undefined. Domain is the same question, but it's asking really where the function is defined, which is, again, the values you're allowed to plug in. All right, X-Intercepts. I've done this so many times, you know that you do 0 equals the function, which is 6 over x minus 3 times x plus 2. Now my requirement next is to multiply both sides by the denominator to eliminate the variables in the denominator. So that cancels with that. On the left, y'all, I have 0. Anything times 0 is 0. On the right, look, I have 6. What? Okay, then my x is canceled out. What does that mean? Well, that means there is no solution to this equation. And if there's no solution to an equation where you're trying to find x-intercepts, that means there's no x-intercepts. So as far as the x-intercept story goes, none. Well, what about y-intercepts? Remember, the rule there is you plug in x equals 0 instead. So I can write this as y equals, because f of x and y over here are the same guy. And I can plug it in the factored version, nothing wrong with that. 0 minus 3 over 0 plus 2. So y is equal to 6 over, that's negative 3 times 2 is negative 6. That reduces to negative 1. So it does have a y-intercept, which is 0, negative 1. Vertical asymptotes, you just take that denominator, x minus 3 times x plus 2. Set it equal to 0. That ought to feel familiar. We got x equals 3 and x equals negative 2 last time we did that. Those are both vertical asymptotes, which is the same place this function is undefined. Negative 2 and 3. What about horizontal asymptotes? Okay, I'm supposed to check out the degree situation. The degree of the numerator, there's no x at all, so that's 0. The degree of the denominator is 2. If you'll remember, whenever the top is smaller than the bottom, so again, you can think about that as an x to the 0. So I really would highlight this instead of the green right there that's not letting me erase what I want it to. There it goes. Oh no, now it's erasing too much because the eraser's stuck. No. Okay, degree 0 over degree 2 is automatically y equals 0. You just have to recognize that, okay? Want to transfer this information over to maybe an inept graph again. There might be enough of a scale there for us to get this done, but we're sure going to try. So, what do I got? verticals of 3, -2, no x-intercepts, a y-intercept of 0, -1, and a horizontal asymptote of y equals 0. Okay? Let me start with my verticals. Okay, so vertical at -3. So 1, 2, here's -3. Purple's not working. There we go. -3 and 2. Now there are no x-intercept. We had a horizontal asymptote of y equals 0. And then what I forgot was my y-intercept. Where are you? 0, -1. Okay, so at 0, -1, I'm going to do this in orange like I've been doing. I finally have 1 point. Everything else is vertical asymptotes. My graph is never going to intersect these vertical lines. It may intersect the horizontal line. We'll find out. All right. Phew. Here we go. Got to figure out what to plug in, right? Okay. So I need some points to plug in. Between and beyond every x-intercept is the rule. So I have an x-intercept over here at -3. Let's plug in -4. Okay. Now I need to plug in something between these two x-intercepts. Hey, I've already got something plugged in, but I don't know if that makes me feel good enough, right? So maybe let's plug in one more point, like -1 or -2. Okay, so I'm going to plug in -2. And then something to the right of this x-intercept over here, maybe like, because that's 2, so 3 or 4 or even 5. So I think I'm going to plug in 3. Where am I going to plug it in? You know what? The original or the factored one. I kind of like the factored version. Remember, it was x minus 3 over x plus 2. So 6 x minus 3 over x plus 2. There we go. And so that would be -4 minus 3 times -4 plus 2. Just be careful and don't do it too fast like I'm trying to do. -4 minus 3 is -7. -4 plus 2 is -2. So that's 6 divided by +14. Hey, that reduces. They both divide by 3. 2. We'll try that again. 2 goes into 6 3 times. 2 goes into 14 7 times. So 3/7. It's not pretty, but we can graph it. Next one, 6 over -2 minus 3 times -2 plus 2. I got a problem. Why did I plug in -2? I've got a problem. I got a vertical asymptote at 3 and a vertical asymptote. Did I get those backwards? Oh, I did. Look, y'all. Hey, that's the good news, though. If you pay attention to what you're doing, maybe you'll find it. And it also didn't do like I wanted it to. Alright, so what I'm trying to do is I'm trying to erase my verticals because I got them mixed up. Okay? Right, this vertical asymptote, hold on, this one's at -2. This one's at +3. You might even been screaming at me in the video because you realized I did it wrong. I'm sorry. So again, right here, x equals 3, x equals -2. See if I have it right now. X equals 3, yes. X equals -2, yes. And so I'm not allowed to plug in -2 over here, y'all. How about -1? Wouldn't that be better? But see, the good news is if you make mistakes like that often, you can catch yourself because things are just not working out like they should. Alright, -1. Here we go. -1 minus 3 times -1 plus 2. So 6 over, that's -4 times 1. 6 divided by -4 is -3/2. Okay, it's still not pretty, but that's okay. And then let's plug in 3. 6 over 3. Whew. That's not going to work either, right? I've already caught my error, but I haven't fixed the things I plugged in. I got to plug in 4. Y'all remind me, why can't I plug in 3? Because there's a vertical asymptote right there. You get undefined. So let's plug in 4 instead. So that would be 4 minus 3 times 4 plus 2. This is 6 over 4 minus 3 is 1. 4 plus 2 is 6. Finally, a whole number. 6 over 6 is 1. Y'all just pause me. Slow me down. If you've got any questions or it's just not working out, slow down and get it done and you'll see, or you'll see that I'm wrong and then you'll email me and I'll go, oh, I'm so sorry, I'll fix it. Alright, Let's plot points. -4, 3/7. So 1, 2, 3, -4 right there. And 3/7 is positive. Now 3/7 is almost half, isn't it? Because 3.5/7 would be half. So 3/7 right there. Might not be feeling real good, but it's going to be okay. -1, -3/2. So -1, -3/2. You know -3/2 is -1.5. And then 4, 1. Now remember, this graph splits into 3 pieces. You got the piece on the left of this leftmost vertical asymptote. You got the piece in the middle between your 2 vertical asymptotes, and you have the piece on the right. So let's look at the piece on the left. Now right here, let's go from point to vertical asymptote. I got to rise up or I got to go down, right? I'm going towards the wall. You either go up the wall or down the wall. Why do I have to go up the wall? Because if I go down the wall, I'm making an X intercept, place that does not exist. So I go up the wall, and then I approach the horizontal asymptote. If we look at the part in the middle, so right here, I got to approach the wall. Either I got to go up the wall or down the wall, right? Why is it down the wall? Because I can't build a new X-intercept right there. Same thing this way. Must be going down the wall because I can't go up and make a new X-intercept that doesn't exist. Over here, I'm running towards the wall. I smash into it. Either go up or I go down. You know I'm going up because if I go down, I'm making an X-intercept that does not exist, and then I'm approaching the horizontal asymptote that way. I know for a fact that this graph does not cross the horizontal asymptote because we already found out it has no X-intercepts. We've already really solved to find out it doesn't cross. So there's your graph. If you type this into Desmos or some other computer algebra system to see what it looked like, it probably looks similar. There's some differences. Mine's way zoomed in and a little bit sloppy, but it should look very similar to that. Okay, last graphing problem of the review. Thank goodness, right? This is taking forever. Okay, so what is the domain of this function? May I suggest simplify first. That's so important. And every one we've done so far factored, but it didn't simplify. Let's see how this one goes. So x squared minus 16, that's x plus 4 times x minus 4. Remember, that's the difference of squares. Denominator multiplies to be 12, adds to be -1. That's x minus 4. Okay, x minus 4 times x plus 3. You with me? -4 times 3 is -12. That's right. -4 plus 3 is -1. Yeah, there we go. Oh, finally, look, 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 look. -4s, boom, gone. Okay, now we're going to see some subtle differences of domain and vertical asymptote. When you find the domain, y'all, you have to do it before you simplify. So imagine those orange lines are not there. I'm setting the entire denominator, original denominator, although after factored is fine, equal to 0. So x is not allowed to be 4, and x is not allowed to be -3. Okay, both of those places are out. So this would answer the question of where it's undefined. -3 and 4. But what about where it is defined, which is the domain? Well, we're defined between -infinity and -3. And we pick back up again from -3 to 4 and pick back up one more time from 4 to infinity. So you could put commas or the union symbol. Both is not required. That is your domain in interval notation. What about x-intercepts? Remember what I said about x-intercepts? Simplify first. So y'all, I'm going to use the x plus 4 over x plus 3 simplified version to find x-intercepts. So that's 0 equals x plus 4 divided by x plus 3. You know the math by now. Multiply both sides by x plus 3. Over here and over here. On the left side, that gives me 0 equals x plus 4. Right side, those x plus 3's cancel. Now, I solve, so subtract the 4 to the other side. That gives me x equals -4. If I write that in point form, that's my x-intercept. Y-intercept. Should you use the simplified version or the original? Hey, I use the simplified all the way around except where I find domain. Okay, so simplified version is good. You're finding f of 0, or you could write it as y equals, and then plug 0 in, 0 plus 4 over 0 plus 3. And that gives me something that's not nice, 4/3, but that's okay. So 0 4/3 is your y-intercept. What about vertical asymptotes? Okay. Now, so far, every problem we've done, A through, oh my goodness, G, then it's the same as finding domain. But finally, this is a problem. It's not the same as finding domain because the x minus 4 is canceled. So it's just x plus 3 equal to 0, which gives me x is equal to negative 3. That's the only vertical. But what about the 4? Remember, there's a hole in the graph at x equals 4. So whenever you cancel out, see my orange cancel in here? That gives you a hole in the graph. Not because you canceled, but because it does cancel. And it just leaves a hole. Just a hole. We'll try to put it on our graph. But the one that stays, the x plus 3, is going to cause us to be undefined at negative 3, and that causes a vertical asymptote. All right, how about the last guy? We got to find horizontal asymptote before we graph. And that's when you look at the cases. And when you look at your cases, you can look at the original or the factored. I think the original might be easier to look at. Look, the degrees match. So whenever the degrees match, I'm going with leading coefficient over leading coefficient, and they're both 1, aren't they? So it's going to be y equals 1 over 1, which is y equals 1. So I have a horizontal asymptote at y equals 1, a vertical asymptote at x equals negative 3. The hole in the graph I deal with last. All right, so let's put that on our graph. So our vertical at negative 3 and our horizontal at 1. So a vertical at negative 3. So there it is. A horizontal at 1. There that is. Let's go back and grab our intercepts. So we have negative 4 zeros an x-intercept and 0 4/3 is a y-intercept. So negative 4 0, right, is an x-intercept, and then 0 4/3. Now, 4/3, remember, is bigger than 1. That's 1 1/3. That's my y-intercept. Well, this is interesting. Okay, now, what do you want to plot? Hey, we've already got a point over here, don't we? Okay, so right here, I'm approaching the wall. Like I'm running to the vertical asymptote. I either run up or I run down. Uh-oh. I don't know. Why don't I know? Because I'm supposed to plot a point between the x-intercept and the vertical asymptote. When you're on the line, how do you know if you run up or you run down? You might think you can't cross a horizontal asymptote, but you actually can, right? So I definitely need to plot something between, so this is fun, I've got to plot something between this negative 4 and this negative 3 value. So how about negative 3.5? It's not fun, but we have a calculator, so it's perfectly okay. Not only that, we need to write the simplified version. Remember, it was x plus 4 over x plus 3. So this is x plus 4 over x plus 3. There we go. Because this is what we want to use. Okay? So I'm going to plug in negative 3.5 to figure out, just do I go up or do I go down? Okay? And I'm supposed to plug in something over here. And I have a point, but I'd feel better if I had another point. Like, for instance, negative 2. And you could even plug in something over here like positive 2. Okay? Extras never hurt anybody. It just takes an extra minute. So negative 3.5 plus 4 in the numerator, and then negative 3.5 plus 3 in the denominator. And that gives me negative 0.5 in the numerator and, positive 0.5 in the numerator and negative 0.5 in the denominator is negative 1. So at negative 3.5, I get negative 1. Let's plug in negative 2. So negative 2 plus 4 over negative 2 plus 3, which is 2 over 1, which is 2. And plug in 2 plus 4 over 2 plus 3 is going to be 6 over 5, which, if you want to change that to a decimal, go ahead. That's 1.2. 6 divided by 5. If that makes you feel better, change them all to decimals when you're graphing. That is no problem. So negative 3.5, I get negative 1. So halfway between, I get negative 1 right here. You know what that means? The graph goes down. Excuse me, and it approaches the horizontal asymptote. Now, my next point, negative 2, 2. That's here. And another point to make me feel better, 2, 1.2. That's here. I think you can see clearly what's happening. If I run to the wall, I can't go down because I can't make a new x-intercept. I only have the one x-intercept on the other side over there, and then this approaches. Okay, now what we didn't do is find out if the graph crosses the horizontal asymptote. How would we do that? Remember, the horizontal asymptote is 1. and you set that equal to your function, which is x plus 4 over x plus 3. But if I multiply both sides by x plus 3 to solve this thing, watch what happens. I get x plus 3 on the left, because x plus 3 times 1 is x plus 3. These cancel out, I get x plus 4 on the right. And then my x's cancel, and I get 3 equals 4, and that's no solution to that. So I never cross this line. And if you just had to guess, usually you don't. It takes a rare bird of an equation or a function to cross the horizontal asymptote, but it does happen, okay? Now, there's this one super important thing that I haven't done. Remember, there's a hole in the graph. Where's the hole? So remember, we wrote it, a hole at x equals 4. So over here at x equals 4, 1, 2, 3, 4, there's a hole in the graph. Notice I don't have anything plotted. As a matter of fact, it'd be a good idea if I plug 4 in to figure out where the hole is. So it's going to be 4 plus 4 in the numerator and 4 plus 3 in the denominator. That's 8/7. That's just a hair over 1. So let me erase a little bit of my orange line right here. And it keeps going. And let me be a little bit more careful with it. Let's erase a little bit more. Okay. It keeps going. And there's a hole at the point 4/8/7. So 4/8/7, just barely above the horizontal asymptote, and I put my hole there. So I'm super duper correct, and there it is. Now here's the problem with my hole. My hole really is no area at all. Like if we were visually looking at that, we shouldn't be able to see it. But I make a big deal out of it, so you realize the function is undefined there. Finally done with the graphing. I'm going to stop the video here and actually do a part 5 to maybe finish all of the work, but these problems took quite a few minutes, and so we'll do a part 5 to start solving inequalities and finally do variation problems. I hope it's going well. Let me know if you have questions, okay?